So now we're going to take a look at how to implement mathematical functions in Python. So basically what we want is a way to make sense of, say, this. Because mathematically, why would we do this? Because we would do this because it's tedious to keep writing this whenever we want to talk about this expression. So if we want to use this function a lot, we just give it the name f. So for instance, if we want to compute f of 3, we'll just write that. And the point is you can do exactly the same thing in Python. So here's how to tell Python how to do this. So we write def f, then we write the list of inputs, which for us would just be an x. And then now what is indented here would be everything that f is supposed to do. So f would compute y, which is x to the square minus 5x plus 4. And then we have to write a special command here, return y, okay? So this means that when I put an x inside of here, this is what happens. And then this guy here gives the value y back to whatever program uses f. So how to use this? So if I run this program, nothing happens because I'm now just defining this guy. But if I now do print f of 3, then I get the value of this function at 3. And if you check it, then minus 2 should be exactly what we want. And I can do now print f of 5, and I can use this expression here however I want. And now just a few words of caution when using functions. For instance, let me now write x is equal to 3. So if you're new to this business, then you would here say, okay, x is 3. Now I'm defining f of x is 3. So y here is computed with x being equal to 3. So if I now do print y, then of course I should get the value of f at 3. But here this crashes because y is not defined. And what happens here is that anything that happens inside of the function stays inside of the function, so to speak. All of these variables inside of here are so-called local variables. They only exist whenever the function is called, and when the function has done what it's supposed to do, all of these guys are deleted. And here in this code, I never call the function f. I'm never asking him to do anything. I'm just defining him. Then I have a variable x here on the outside, means nothing to this guy, and the variable y inside of here just exists inside of here. So this y means nothing on the outside here. So what I will need to do, if I want to do anything, well, I can keep my x is equal to 3 here. And then I now can do print f of x. Down here now x will have the value 3, and I'm getting what I'm supposed to get. So why is it like this? Well, for instance, we have the sum function, right? So if I now make a list here, a is equal to 1, 2, 3, and then I write sum a, well, I get its sum, and I need to print it to see what it becomes. Then what happens here is that the sum function is defined. I mean, it's defined and its code is somewhere on your computer, okay? And inside of the code of the sum function, you have a lot of variables. And of course, you don't know what names the people creating Python used when making this sum function. And for instance, if it wasn't so that all the variables inside of here only existed inside of here, then you could be unlucky. Because for instance, when you run this sum, well, what if they call something n inside here? Then you could risk that, well, when I print, if I up here to n is equal to 2, I run the sum function, he puts n is equal to 3 perhaps because it sees 3 guys here. And then if this variable inside of the sum function still exists when the sum program is over, this value of n that we created here would have changed. And that would make it impossible to program anything because we would need to know in detail what variables are used inside of all these functions that exist in Python. So for this reason, we don't really want the variables that are on the outside and inside of functions to have anything to do with each other. So they're put in separate universes. So for this reason, I can be sure that when I run this program, n will still have the value 2 down here, which you can see. So that's the reason why we keep these namespaces separate.